Hello, beginning linear algebra students. I'm looking at section 2.4 from the book Linear Algebra with Applications, which is an open educational resource. The link will be pasted below the video. I'm looking at problem number 35, which is kind of how you can identify if a matrix has an inverse or not. In this case, the problem says, show it's not invertible because you can find a matrix Y such that y times a equals 0. Now, if it was invertible, then if we had this equation, that says the matrix Y would have to be 0, 0, 0. And we'll probably show the same thing with B. Okay, so I was super ready to hop onto Desmos, see if this hint 3 to negative, what is it, 1 to negative 3, except backwards. Okay, I hopped onto Desmos. So I've got an A matrix and a B, and I was just trying A times B, and let me move this over a smidge so you can see the answer. Oh, well, maybe it was supposed to be a negative here. Positive here? Negative here. This wasn't working, and I realized what I was doing was called plug and chug. So I said, all right, is it actually invertible? I didn't even check that. So let me just see if it is. And it says, no, it doesn't have an inverse, it's singular. Okay, so that's one clue. It told, okay, it really doesn't work. Let's just see what the determinant is. Another big clue right here. It's not invertible because the determinant is 0. So I said, all right, okay, back to the clue. Oh, look, the Y was in front. So I'm going to write out Y, write out A, write out the 0, and come up with 3 equations. And I messed up a couple times. For instance, I wrote the negative 7 down here instead of up there, and I forgot that was negative because it's over here. I was looking over here. That's why it's in ink, but I can make an augmented matrix from this that looks like this C. And when I do reduced row echelon form, I'm going to find, remember 0 equals 0 is a perfectly fine answer. And we just say y3 is a parameter, y2 is then negative twice the parameter, and y1 is 3 times the parameter. So that gives us some possible y's of 3, negative 2, 1, or negative 6, 4, 2, or 0, 0, 0. It just depends on what you want your t to be. So back to Desmos. Okay, I'm going to get rid of, clear out B, new matrix. So I just need 1 row, but 3 columns. See, what was that answer? Okay, so negative 6, 4, negative 2. Now let's see what AB equals. AB, sorry, it's in the wrong order. They don't even match up. So let me get rid of the A and write it behind. So it's BA. And is 0, 0, 0. So we can show that there exists at least one, and it's actually, we can have more than one. What if I put zeros? 60, 40, 20. See? Still get zeros. All I did was multiply by 10. You can have an infinite number of matrices, in fact, that B times A will give you a 0 result. So when I went to B, I thought, okay, I can do the same thing. And just, okay. So because it was columns instead of rows, then maybe I needed to look at a column matrix. So I wrote this down and for some reason wrote y2 instead of y1, although it's in the y1 spot. And in Desmos, I said, okay, this is C. Trying to get it where you can see. Okay. All right, so 1, 1, 2, 3, 0, negative 3, 2, 5, 17, and 0. So the augmented, and if I do reduced row echelon form, I'm going to come up with a row of zeros on the bottom, which is fine. And in fact, this is what I can put in terms with parameters. So I can get 1, negative 3, 1, which I think is in the back of the book. But I could also do 4, negative 12, 4. I could do 10, negative 30, 10. See, again, I can get an infinite amount. And one more time, Desmos. Okay, so I actually simplify it to E, and then I'm going to get it E. New matrix, it's going to have 1 row, but 3. Is that the right way? Nope. It's going to have 3 rows, but only 1 column. So, what was it? 10 and negative 30 and 10. Then, let's see. E, D. Yep, there we go. A zero matrix from non-zero multiplication, indicating E does not have an inverse. In fact, let me show you. E inverse, singular matrix. If I did the determinant of E, oh, clear. Determinant of E, I still get 0. Okay, 3 indications that the first 2 matrices from the slides, A and B, are not invertible. Thank you.